This is a demonstration and motivation for developing software that makes avatars produce more natural and convincing motion. What we're doing is trying to identify what biomechanical kinematics we can infer from linguistic data, and this is a discussion of a case study for roll shift. You have some software available to you that you can use to look at and explore the different types of motion that are alternatives for avatar movement. Okay, in the software, we're going to do a quick tutorial on how to set up the software, and then we'll see it in action. So unzip the zip file, double click on the ball and stick.max, which is the 3ds Max file with the ball and stick figure in it. This will activate Max. Then inside of Max, to run the software, go to the Max Script menu item, click Run Script, and in the File dialog box, pick uimain.ms. The software has two panels in it. In the first panel is several items having to do with setting up the basics of your roll shift. Okay, the first one, direction or heading of the shift, has to do with the orientation of the signer when the signer assumes the role of a particular protagonist in the discourse. So at some point there's a translation between the orientation of the protagonist, and that is translated into a heading. So we're just going to start with a numeric for the heading, and this is given in degrees. Then the second item that you set is the duration of a shift. We're suggesting that as a first try that a duration of somewhere of 30 frames, which works out to a second, is a good number to start with. And the onset of any shift that you create begins at the current slider time. So if you want to make a shift and then you want to make another shift, then you're responsible for moving the time slider yourself. You'll see this in the demonstration. The next thing you see on the list is a choice of transition type. Now, pose sets the keys at the destination of the shift. This is a direct implementation of the classic Liddell and Johnson movement hold model. Is that what you're doing is you say, here's the hold, interpolate up to the hold. So all of the joints rotate in synchrony. Okay. In contrast, we're introducing a new type of transition, a turn, in which the joints don't move in synchrony, but the duration of the onset of each joint rotation is staggered. In both transition types, the avatar ends up in the same position at the end of the transition. It's how the individual joints get there that changes. When working with a turn, you also have options for adding additional arm and leg motion. And then after you create these settings to your taste, you click Animate, and the animation set up, and that you see down here also you can also clear your animation. Okay, now in panel 2 has to do with the fine-tuning of the transition of a turn. That's contrasted with a pose. Okay, first of all, you have a set of delays, and this is how quickly do each of these components start the transition. So as you can see, the eyes start right away at time 0. 10% of the duration later, the head starts, okay, and at 15% of the duration delay, the neck starts. Okay? And then down here you see in the second row are the durations, again given in percentages. And so you can adjust these and experiment with the timing. And you can save the timings off into a text file and load them back in for future work. Okay, there's a correspondence between those delays and when the motion starts for a particular component. So as you can see here is that the waist starts before the chest or the shoulders, and the neck starts far earlier. Continuing on, the eyes start first. Head is next. Okay, and then the hips. Okay. Well, with that, let's see the demo. Clear that away. Okay, I have the roll shift package unzipped here, and I'll start by double clicking the ball and stick figure to bring up 3ds Max. Let's bring the screen over here. And we'll make this a little bit smaller so we have room for the panels. Okay, now under Max Script, I'm going to run the script. And where have I got that? And I select UI main. And now we can see the two panels. And so for the first setup, I'm going to create a pose. I'm going to create a pose that it's a 30 frames in duration and has a heading of 20 degrees. So I'm going to hit animate, and the time slider moves forward those 30 frames. And I think I'm going to let it stay put for about 30 frames. And then what I'm going to do is move the heading back, and again hit animate. Okay. Now, if we run this, it's a quite robotic motion. As you see that the eyes are still, you get what we call doll eyes. It's not particularly natural. So let's clear that animation, and this time let's do exactly the same poses. Let's do exactly the same headings at the same time, but this time let's make it a turn instead of a pose. So we're going to start out with a heading of 20 with a duration of 30 frames. So we animate that, and then we are going to let the avatar sit there for 30 frames. So at frame 60, we'll do a rotation back to and a duration of 30, and we'll animate that, and let's see what it looks like. So now the different joints start and end asynchronously. To give you a better feel for what's happening, I can go in, I'll clear the animation, and this time I'm going to create a heading, more extreme heading. And I'm going to make it not 1 second, but make it 4 seconds long so that it spreads out the motion and you can see the individual joints moving. Eyes first, then head, then hips, then shoulders. Okay. Visual animation. And visual animation at 0. This time I'm going to work with the fine tuning a bit. I'll go back to a more reasonable set of durations for frames. And the way we have this set up right now is I can delay the chest by, say, making that 60%. Now, if I make it at 60%, really, I want these to be add up to no more than 100. So I'm going to change this so now the shoulders are going to start much later and snap around. So I've got my heading of 20-ish. I'm going to say animate. I'll move this back, transition back to 0. Hit animate again. And now this time when I run it, the shoulders move much later and they have more of a snap to them. So that's the underlying model for the motion, and we have a demonstration on a live avatar. Now we have on a fully rigged avatar. Now with this particular sentence that you're going to see is that the first part of the sentence involves an index, okay, a point, and we haven't got this new algorithm migrated into indexing yet. So you're going to see the bad old motion with the doll eyes and looking very robotic. And then at the end, you'll see a roll shift and a return from a roll, and you'll see that the transitions in terms of the turn are much more natural. So here we start robotic and more natural. And I thank you for your time.